Okay, a very warm welcome to everyone in this webinar about water sector threats as seen through the lens of the MITRE attack framework for ICS. Please feel free to ask questions during this webinar. You can type them in the questions box and we will answer them at the end of the session. Also, please provide us with your feedback at the end of the webinar so we can learn from you and improve future webinars. Let's introduce ourselves. My name is Remco Huisman. I'm a senior account manager and partner at Secura, 20 years already, and I'm focused on the critical infrastructure.
My name is Jos Wetzels. I'm a principal consultant and security researcher at Secura, where I primarily focus on various kinds of embedded systems that are found in ICS and automotive domains. And I previously worked as a researcher into the security of critical infrastructure at the University of Twente in the Netherlands.
Let me take a minute or two to introduce Secura so you quickly get to know the company and our services. Secura has almost 20 years of experience in IT and ICS security. We're based in the Netherlands, about 100 people in size, and we work worldwide for different sectors and many national and international clients in the critical infrastructure. We're a specialized IT and ICS security company with 4 focus areas. This is our general portfolio. I will get to our ICS offering in the next slide, but would like to mention here that we are only one of the few labs to do BSPA assessments. BSPA is a security certification program for the Dutch government, set up by the Dutch Central Intelligence Agency. Secura also is a certified common criteria lab, which is a more international certification standard. Looking at our portfolio, we can assist organizations in almost all aspects of IT and ICS security. Many companies in Europe are struggling with the NIST directive and ask themselves, do we comply? To help them with this question, we do a gap analysis against, for example, the NIST or IAC 62443 standard. We can also assist organizations to develop and execute plans closing the gap so they are on the right track towards compliance. For the technical people, we provide classical or in-house ICS security training and ICS hands-on hacking workshops. We also offer a security awareness program that is focused on changing behavior. Awareness should, of course, never be the end goal. The program contains complementary e-learning with an ICS module that can be tailor-made to your organization. We also provide threat modeling, OT, site and risk assessments, design reviews, and penetration testing on IT and ICS systems and devices. Let me tell you a bit more about SOC SIEM testing and red teaming. Many companies have set up their own SOC SIEM solution or have outsourced it. To our experience, these solutions are hardly ever structurally tested. So we have developed a SOC SIEM assessment to do this. With this assessment, we can determine if you have the right use cases, if you detect certain attacks of the MITRE attack framework, and at what threshold. The results we had so far are a bit shocking, as about 40% of the attacks will not be noticed at all. Lastly, red teaming. Red teaming is an important approach to really test the cyber resilience of organizations. Testing the cyber resilience in the critical infrastructures is very important, but can be risky. We have developed an approach where we combine our red teaming experience with our ICS expertise to perform realistic attacks without risk, aiming at a maximum learning effect so organizations can raise their cyber resilience. That this is necessary will become quite clear in the presentation of Jos Wetzels. Jos, the floor is yours.
All right, thanks for the introduction, Remco. So today we'll start with a bit of background information, and then we'll look at what the MITRE attack framework for ICS is all about, which we'll illustrate with a couple of case studies before working our way towards a conclusion. Now, the content of this webinar is applicable to the world of ICS in general. We focus specifically on the water sector, however, which in the Netherlands consists of various utilities and bodies dealing with water treatment, distribution, and management, parts of which are classified as Category A vital infrastructure. Now, like all ICS environments, over the past years, the water sector has become increasingly digitized, networked, and especially these days, remotely managed and hence increasingly exposed to various cyber threats. And as you can see on the slide, these threats can be composed of a variety of different actors, motives, and means, ranging from targeted, sometimes politically motivated, state-sponsored attackers looking to potentially sabotage infrastructure to opportunistic, financially motivated cybercriminals trying to extort utilities. And really, over the years, the water sector globally has really seen just about every corner of the spectrum here, as we'll highlight in a couple of examples that we'll go through. One of the categories that has troubled the water sector has been the category of disgruntled insiders. The most famous example being the Marucci incident in Australia in 2000, where a disgruntled contractor manipulated the sewage treatment SCADA system with a rogue RTU and released over 1 million liters of raw sewage into the environment, causing serious financial and ecological damage. And this isn't the only example of an insider with privileged access going rogue, with an incident in 2007 in the US involving an angry Canal Authority electrical supervisor damaging a canal's SCADA systems, and a 2014 incident where an employee of a smart meter vendor tampered with water bills and the RF infrastructure of 5 different utilities, causing serious disruption. And this really illustrates this kind of insider threat well. Now, these threats can be purely opportunistic as well, rather than disgruntled insiders, especially as we've seen over the past years with waves of ransomware and crypto miners, some of which have made their way into the OT networks of water utilities and have disrupted operations there. But the real focus of this webinar is by far the most worrisome category of these attacks, which is outsider attacks focusing on a cyber-physical impact. In the past years, there have been 3 such publicly documented attacks on water sector targets, ranging from reconnaissance attempts against the dam SCADA systems in New York to attempts to manipulate chemical levels and flow control, which we'll delve into a little bit later detail. Now, partially as a result of such incidents, the cybersecurity of the water sector, both internationally and in the Netherlands specifically, has come under a lot of public scrutiny, causing various players to really ramp up their security efforts. A great place to start with those efforts is always with the fundamentals. And there are various standards, guidelines, and best practices available, ranging from the NIST directive and ISO 27000 to IEC 62443. But it's important to realize that while being a good first step, being compliant is not the same as being resilient. It's the difference between getting your driver's license versus actually driving safely. And a big question that people often struggle with when trying to go beyond compliance is to know how to effectively prioritize our security investments and structurally evaluate them against real-world threats. And this is precisely where the MITRE attack framework for ICS comes in. MITRE attack is a knowledge base of adversary tactics, techniques, and procedures that is based on real-world incidents and research. It's a free, open, and community-driven common language that's spoken by both industry practitioners on the offensive side as well as security solution vendors, and that allows us to break down incidents into granular, testable pieces of knowledge. Secura has contributed to MITRE attack for ICS and also integrates it into its various ICS security offerings in order to be able to make them more translatable to your already existing security efforts. Now, there's a wealth of use cases for MITRE attack, including, for example, enhancing the realism and prioritization efforts in your threat modeling, or informing your architecture, design, and security controls, providing the basis for use cases in your SOC SIEM design, and prioritizing the collection sources in your monitoring efforts based on the artifacts that are likely left behind by real-world TTPs, as well as helping you set up faithful adversary simulation efforts. Now, the classic attack frameworks are enterprise-oriented, and they cover the traditional attack lifecycle from early reconnaissance efforts, as modeled by the MITRE pre-attack framework, all the way through compromise up to executing on an attacker's goal, as modeled by the enterprise attack framework. It does this by mapping observations about real-world incidents and research to so-called TTPs, tactics, techniques, and procedures, which describe a way of analyzing, simulating adversary operations going from the most broad, the tactics to the most specific procedures, with this procedure being a detailed implementation of a technique, which is a way to achieve a particular goal associated with a tactic. In order to illustrate this a little, consider the example of trying to achieve persistence on a target system, which is a tactical goal. One technique to achieve that is scheduling a task using the native task schedulers of the operating system. ATT&CK has different sub-techniques for that, since it's a rather broad technique, including using cron on Linux or using the Windows task scheduler. Finally, there would be a specific procedure implementing using these sub-techniques, such as certain families of malware, like the Speak-Up Trojan or the Powersploit framework, which can then be implemented or tested or added as a thing to watch for in your forensics efforts. On top of providing a knowledge base with TTPs, ATT&CK also provides a variety of corresponding mitigations for the techniques that are listed, which helps you in really robustifying your defensive efforts. Now, currently, it doesn't have these mitigations yet for the ICS framework, but there's enough overlap for that part to be useful for the world of ICS too. Now, ATT&CK for ICS is a relatively new initiative by MITRE that's not meant as an alternative for the enterprise-oriented framework, but it's meant to be complementary, with the real differentiator here being a focus on attacks with a potential cyber-physical impact. That is, disruption of essential ICS functions, such as safety and protection, availability, control, quality assurance, and those kind of things. Now, do note that it is about potential impact. Sometimes ATT&CK for ICS might not be the right fit for you, even if your primary domain of focus is OT, because the threat in question simply doesn't impact operations. It might be the case for certain families of ransomware, for example. In other cases, you might not think of yourself as having a focus on OT security within your organization, but ATT&CK for ICS might still be the framework to use for certain types of attacks, like attacks on building systems or medical systems. Now, this difference in technical content as well as attacker goals really influences the way adversaries operate. Often, an attacker would get in at the IT systems at the higher Purdue levels that you can see at the top of the right-hand side of the slide, and then they would laterally move down to OT. The intermediate stages between the planning and the conceptualizing of the cyber-physical attack and executing on it are well modeled by enterprise TTPs. But if cyber attacks were a little bit like a hamburger, the difference for ICS attacks are really in the buns. That is, the first and the final phases. And as such, the focus of ATT&CK for ICS is on the lower levels of the Purdue model. And this results in tactical differences with respect to the enterprise framework as well, with a couple of special tactical categories being introduced specifically for MITRE ATT&CK for ICS. First of all, there's the category of evasion, which is concerned not only with an attacker evading security measures, but also process operators and process monitoring from spotting the attack. Then there's the discovery and collection tactics, which are concerned with attacker efforts into acquiring as much knowledge about the process as possible. And finally, there's impair process control, which is a tactic that's all about manipulating, disabling, or damaging control processes, as well as the inhibit response function tactic, which is about preventing a response from process operators and safety systems that might mitigate the attack's impact. So let's take a look at this high-level framework through the lens of a couple of case studies drawn from the water sector. The first case study I'd like to delve into is that of the Kumuri Water Company, which had an incident in 2016. Here, KWC, which is a pseudonym, asked Verizon to conduct a routine security assessment during which Verizon discovered that the threat actor was already present on the network. Afterwards, it turned out that the assessment was probably ordered reactively since management had been aware of unexplained valve movements in the past 60 days. According to the reports, what happened is that attackers found an SQL injection vulnerability in the water company's online payment portal, which they combined with some spear phishing to get access to the web server. On this web server, they then found a file which held the plaintext credentials and the internal IP of an IBM AS400 server, which is quite a legacy system. This server could be accessed from the web server without any kind of network segmentation being in between, and they could log on to it with a single administrator account with no multi-factor authentication. It turned out that this AS400 system held both the payment systems, the customer data, and the SCADA applications, all on one system. Now, at the top of the slide, you can see how the various technical aspects of this incident are mapped to different TTP categories, exploiting a public-facing application, phishing, and valid accounts. Once the attackers were on the AS400 system, attackers manipulated the flow of the chemicals twice by modifying system parameters. Luckily, however, that caused alarms to trigger, which caused the operators to intervene and prevent any real impact. You can see that this type of approaching process control impairment can be modeled with a very generic category of modifying the parameter. On the downside, however, the attackers did manage to exfiltrate 2.5 million customer data records, which can be modeled using the attack for enterprise framework using the exfiltration over C2 channel technique. So if we were to map this incident to attack mitigations, it'd look something like this, where we can see that proper auditing could have caught the SQL injection and proper user training would have helped against phishing susceptibility, while proper account, credential, and segmentation management would have made moving between this compromised web server and the SCADA system that much harder. Now, preventing process impact, even if the system had been compromised, could have been helped by deploying secure OT programming practices and OT-specific monitoring solutions, while exfiltration of the customer data would have been hampered by installing proper data loss prevention solutions and encrypting sensitive information. The second case study that I'd like to delve into is very recent, and it concerns attacks on the Israeli water sector that took place in April of this year. There's relatively little background information on this incident, but that makes it a good illustration of how to make the most of the attack framework with this minimal information that's available. Now, this incident consisted of a series of attacks against water sites in an agricultural region and in the center of the country, where attackers reportedly attempted to manipulate the chlorine levels. These sites were fairly remote and likely connected to the SCADA system over the internet by means of cellular gateways, which render the PLCs either directly or indirectly exposed to the internet. Reportedly, there were no credentials or default credentials which were used on the gateways and the PLCs in question, which is a very similar situation to the attacks on the Bowman Dam in the United States years earlier. Now, before this webinar, I did a quick scan of publicly exposed Israeli PLCs on the internet, and what I saw is that quite a few OT protocols were directly exposed to the internet on devices that also hosted a management interface for the cellular routers, which could be a coincidence. It could be the fact that these are honeypots, but there were quite a few of them, and it's interesting to see how many of them were still exposed to the internet. Once connected, the attackers communicated with the PLCs using standard OT protocols on common port like the Siemens S7COM protocol, Modbus TCP, or the General Electric SRTP protocol. And then they used these protocols to modify the control logic and the parameters on the PLCs, likely using vendor engineering software. This implies that for PLCs where that is the case, that if there were any key switches regulating the programmability, they were left in programmable mode, or they could have been overridden in software. And it shows that the attackers had at least some basic OT knowledge, as well as probably some degree of process comprehension if they were tampering with these parameters and the control logic. Finally, once they achieved these tactical goals, the attackers attempted to increase the chlorine levels, and depending on how complex this attack was, this could have led to chlorine poisoning, or if excess chlorine was detected at a later process stage, it could have led to pumps shutting off during a heat wave, which is also a terrible potential consequence. Now, luckily, the attack was detected in real time, according to the authorities, and the actual impact was prevented. As far as mitigations go with respect to this scenario, properly segmenting and restricting access to the sites in question would have been a top priority here. Like, these systems do not need to be exposed to the internet. Having an early audit of what is exposed might have uncovered these systems much earlier and prevented them from falling prey to the attackers. From the process protection point of view, secure OT programming and monitoring practices could have aided in reducing potential impact. For example, setting the PLC in non-programmable mode as it is running, using a physical key switch, using integrity checks on the PLC logic and the parameters, locking or limiting the ranges of the set points for chlorine levels, for example. Now, one measure that was taken in the aftermath of this incident was that several water utilities installed an out-of-band monitoring system where they had live fish in various tanks that sampled parts of the water, and the fish were monitored for suspicious activity using cameras and the likes, where the little fish would react faster to changes in the water, while the bigger fish would react to buildup effects in water quality over time, serving as an out-of-band early warning system for water quality changes. Now, for the final case study, I'd like to draw upon some aspects of offensive research that have been conducted in industry and academia. And the attack scenario in question here is the so-called water hammer attack. A water hammer is an effect that you might know from your home when you close the valve on your tap too quickly, and it occurs when you rapidly close a downstream valve on flowing water, causing a pressure wave to travel upstream from the valve and reflect back, which causes vibration and potentially displacement and rupture of piping infrastructure. An attacker could seek to open and close valves multiple times even at the right moment in order to cause an additive effect to that initial pressure wave, causing more damage than the sum of its parts. The feasibility of such an attack, however, depends on many factors, ranging from pipeline design, mitigating measures, pressure ratings, pump capacity, valve closing speed, and all those various factors. But you really need to ask yourself, does my design reflect unwarranted faith in the integrity of the digital systems that are controlling it? If your control and your safety systems fail, is the residual risk still acceptable to you? That is the key question when it comes to attack like these. Now, going into the details of an attack like this is beyond the scope of this webinar. But what's important to realize here when it comes to analyzing such an attack through the MITRE attack lens is that while much can be achieved by abusing regular ICS functionality, as we saw in the Kamuri incident and the Israeli incident, an attack of this kind likely requires more sophisticated means than changing a few set points or modifying some PLC logic. You'll need a high degree of granularity, coordination, and execution speed in your attack, and you possibly need to overcome field equipment limitations that you cannot do using regular means. So in order to achieve this, an attacker will likely opt for placing implants on control and safety devices themselves by modifying the system firmware, either through malicious firmware downloads or code execution vulnerabilities. An example of such an implant being used in practice against an OT target was the Triton malware, which in 2017 targeted a TriConnect safety system by Schneider Electric used for burner management in a Saudi petrochemical facility. Now, this didn't have an actual safety impact because of a bug in the malware itself, which caused a plant shutdown before anything really serious happened. But it does show that attackers are thinking about these kind of capabilities and are even willing to deploy them in situations where lives might be at stake. Such an implant could, for example, be used to override safety checks residing in the firmware of valve controllers or pump drives, which might be a limiting factor in, for example, being able to close a valve with a certain speed. Or it might allow you to manipulate in a very stealthy fashion the inputs and outputs as they are coming in or going out from the PLC itself, as well as suppressing any alarms that are raised by safety logic residing within it, all of which can be modeled with the corresponding MITRE attack TTPs at the top of the slide. Modifying system firmware, modifying module firmware, manipulating the I/O image, and suppressing alarms. And this allows you to take a complex and deeply technical scenario like this and analyze it in a structured and high-level manner to evaluate your own cyber resilience against these kinds of scenarios. Of course, it's important to realize that attacks like these, they really require a significant degree of process comprehension. Attackers need to know about the control design, about the safety design, about the interdependencies of the process itself, about the alarms and the way alarm management is done on this particular system, about point and tag mappings and all these kind of intricate details. And that means that attackers will need to come looking for pieces of information like network diagrams, asset inventories, process flow diagrams, piping and instrumentation diagrams, and historian databases, all of which hold this precious information. Attackers might come looking for this at the higher Purdue levels, SharePoint repositories, mailboxes, all of which could be modeled using the traditional enterprise attack framework, but it might also collect parts of this automatically within the OT networks themselves, as for example, the HAVEX Trojan did, which was utilized a couple of years ago against various electrical utilities, and which used the OPC standard to automatically harvest information about OT systems. But you'd be surprised how much of this can already be done in the preparatory stages of an attack. Especially in heavily regulated public sectors, there's a wealth of open source intelligence to be found. On the slide, I've included some safely redacted examples from the Dutch water sector, and with a few simple searches, you could see that it was possible to obtain network diagrams, asset inventories, and detailed field bus and alarm mappings from publicly shared documents. And with this thing in mind, it's important to realize that the availability of this kind of information might actually be a factor in getting opportunistically targeted, as has been suspected to be the case in the Israeli water sector incident, as well as the Bowman Avenue Dam incident, which were likely targets that weren't specifically chosen for any strategic importance, but just because they were heavily exposed. There's also been speculation that the attacks on the Ukrainian power grid in 2016 were largely due to the high degree of availability of detailed information about this particular targeted utility. Now, using the MITRE pre-attack framework, one can simulate the preparatory phases of such an attack and get a feel for the degree to which they are publicly exposed here and factor that in to their own risk assessments. So, in conclusion, MITRE ATT&CK for ICS is a free, open, community-driven, and realistic knowledge base that serves as a common language to structure a wide variety of OT-focused security efforts, which allows practitioners to effectively prioritize their security investments and evaluate their efficacy against real-world threats. If you're interested in more ICS-oriented webinars, we have two excellent ones available for you on red teaming in OT environments and performing OT risk assessments, which you can check out for free at the top of the slide. I'd also urge you to save the date for the 29th of October when we have an upcoming webinar on the OT security risks of remote access and maintenance, which, especially given the current COVID situation, is highly relevant to many asset owners out there. And with that, I'd like to switch to our Q&A. If you have any questions, as Remco said, don't hesitate to ask them. We'll try to go through them and answer them. If you have any questions after the webinar, don't hesitate to send us an email and we'll get to them later when we publish the webinar.
Thank you very much, Jos. We had quite some questions coming in. I will ask them to you and I hope you can give an answer to them. I start with a very plain one I can answer myself. Can I get a copy of the slides and use them for some of internal awareness? We'll have to look about that, but certainly the recordings will be available. Another question, does MITRE pre-attack generalize also to ICS?
That's a very good question. So as things currently stand, pre-attack was designed mostly from an enterprise point of view, and it does not include specific ICS-focused tactics. And I think this is something that in the future will probably be developed. However, there is always a degree of overlap. So if you're simulating these initial phases of an attack life cycle, there's many things that are similar between the world of ICS and the world of enterprise that you can perfectly model using the current pre-attack framework. Of course, there are certain other aspects, such as drafting, for example, failure scenarios when constructing a cyber physical damage scenario that are currently not being modeled there. And that is something that we're probably going to see being developed in the future.
Okay, thank you. Another question, are defining use cases important? If yes, from which perspective is the best way to define them? Example from the ATT&CK framework or actor or motive.
I'm not quite sure I got the first part of that question.
Is defining use cases important? And if yes, from which perspective is the best way to define them? Example from the ATT&CK framework or actor or motive.
It kind of depends. It really depends on like your specific situation. Like there's various ways, obviously, to start defining a use case. One of them is departing from the perspective of motive. That's really useful if you have a very mature risk analysis where you know the kind of threat actors that are out there, their motives, and you've ranked them and you've prioritized them, and then you can factor that into your use cases. If the picture you have of the threat landscape that is out there for you specifically is a little bit more foggy, then to be honest, I would go for use cases that are defined on the basis of generic actors and that focus a little bit more on the technical side of things, like have a generic actor that fits within that particular TTP perspective.
Okay, thank you. Another question, were the open management interfaces on cellular PLCs discovered through Shodan?
Yes, that's right. These were found using Shodan, and I'm sure you can find them using some of the other OT-oriented search engines as well. I just took a brief look, and it turned out that there were actually quite a few exposed sites that had cellular routers and OT protocols. It might be that they're actual infrastructure. It might also be that they're honeypots. But I thought it was interesting that there were so many of them, specifically in Israel, and closely geolocated to some of the regions that were hit.
Okay, thank you. Another question about the Microtech phases. Are they comparable with the Cyberkill chain?
Yeah, they're comparable. Like there's many models out there. There's the Sense Cyberkill chain for OT, which is one way to think about this. That looks at a little bit of a more high level perspective. So they're complementary, I'd say. Like if you want to conceptualize your attack from a more strategical level, then maybe you want to think about it using the Sense OT Cyberkill chain. If you want to look at it at a little bit more granular of a level, that's where MITRE attack comes in, which is really about trying to tie the technical nuts and bolts back to the higher strategic picture by means of TTPs without losing the forest for the trees in all the technical details that are out there.
Okay, thank you. Another question, what is meant by Purdue levels?
So Purdue levels are a model that comes from the manufacturing industry, where you essentially organize the various levels of an automation infrastructure, all the way from at the bottom the process level to the automation equipment at level 1 to the supervisory levels at 2, and then plant manufacturing. And essentially the way you can look at it is it goes from the cyber physical systems really all the way up to the IT systems on the business side of things where they're integrated with. So it's a particular way of looking at system and network architectures that's specific to OT.
Okay, thank you. Another question, because the questions are still coming in and we still have time, so I keep asking you. I see you mentioned a testbed, Wadi in Singapore. How important are realistic replicas of physical assets to better understand OT attacks and their effects? Can the potential benefits justify the expenses for building and running these replicas for the water sector?
It kind of depends. The actual physical field instrumentation devices in some cases might be worth investigating. For example, if there are certain operational limitations on their physical capabilities, such as, like I mentioned, the closing of a valve speed or something like that, when they're regulated within the digital part of the system, like a valve controller firmware, then maybe you want to investigate that. But that is a highly technical detail. It's something that's worth investigating when you're trying to simulate a highly realistic attack. But from the bigger perspective, if you want to model, a water hammer attack, or if you want to look at the resilience of the overall system, then really the field instrumentation devices, and having, whether you have physical ones or whether you have emulated ones, is not really a significant detail if you're looking at it from that perspective. So it depends on how deep you're going to zoom in on the technical details of the attack.
Okay. Another question about Purdue, but now on the Purdue model. Is it still valid while taking into account IIoT?
Yeah, that's really interesting. There's like a long discussion where people are saying Purdue is dead, especially with the introduction of industrial IoT, where you have field devices, that might be living at level 1 or even at level 0, whatever. And they have like smart functionality and hyper connectivity, where you might have a PLC or a pressure transmitter that is directly talking to some system at level 2, or even to the cloud, if you want to really take those kind of risks. So yeah, I think it's good to realize that Purdue it's a model, and the map is never the territory. The way you use these kind of models from a security perspective should be as a way to structure your boundaries. So to say, I want to take these systems and I want to draw a boundary around them and then enforce that perimeter. And I want to do that at these particular levels. Even with IIoT, you might compress certain levels and you might get to a reduced Purdue, for lack of a better term. But I do think it still remains very useful as a way to think about segmentation and perimeter enforcement.
Okay. Another question: does Microtech for ICS generalize to models which are different from the Purdue one?
That's a good question. I mean, like I said, a Purdue it's a model, and the way Purdue is wielded in different sectors tends to be a little different. Sometimes like if you look at the electrical sector, obviously the way you're going to model what is considered field instrumentation and what is considered a PLC and what is considered supervisory controls, and at what level you allocate that differs a little on the technical details of the sector. So there's always going to be sectoral differences in the way you wield this. I do think like the main takeaway of trying to segment these high level categories within a cyber physical infrastructure is relevant even to different sectors, even if the technical differences might diverge there.
Okay. That's another question. Do you have any specific ICS awareness training modules, not just general security, cybersecurity awareness? I will answer that, and perhaps you can also say something about it, Jos. But yes, we do have, but it's a bit difficult to describe right now. So the person who asked this question, we will contact them personally and get into that. Another question is, what do you think present more risk, insider attacks or outsider attacks?
That's generally speaking, that's super hard to say, because like when you're talking about a threat, there's no such thing as a general threat. Like that's something that doesn't exist. There's also always a threat to something, to someone. A threat always has a specific relationship to what it is that is being threatened, and that depends on various aspects. It depends on the industry you're involved with. It depends on the sector you're involved with. It depends on your geopolitical context. Like the threats that are prioritize to, I don't know, the water sector in the Netherlands are obviously going to be different than the water sector in Israel. And the threats to the petrochemical industry in the US are going to be very different to the petrochemical industry in Southeast Asia. So you can only analyze the priorities of these threats within a very specific context. And I think it is within that context that you should do your threat landscape analysis.
Okay. Another question, where can you find attack information that you can model? Real life attacks seem much more impactful than theoretical attacks.
Yeah, totally. This is one of the big problems in ICS security, having like a real world knowledge base of cyber attacks, because there's a relatively, like compared to IT, where attacks are happening every second of the day. In OT we have like only a small set of publicly documented attacks to work with. I mean, there's more incidents, but some of these might reside in classified databases. They're never going to be shared with the outside world. So there's really two things. Or three ways to draw upon real-world information. One of them is drawing upon the well-known repository of attacks against OT systems, the Ukraine, Stuxnet, Triton, those kind of incidents. The second is trying to draw upon IT incidents that have a high degree of similarity or would be highly translatable to the world of OT. I mean, ransomware is something that affects all of these domains. So that is something where you can draw upon real world incidents that are mainly occurring within IT. And the third is drawing not upon real world incidents, but upon research that's been done in academy, research that's been done in industry that models realistic attacks. Like if these attacks have been presented and shown to be realistic, then even if it's not something that might have occurred as an incident in the real world, it is still a realistic possibility that you might want to take and feed into your use cases.
Okay, final question then. Do you think that historic cases are taken seriously by the water sector? The historic cases you sketched?
I cannot speak, like I'm not a part of the water sector. I cannot speak on their behalf, but I do get the feeling that people are taking historic cases very seriously. It might be the case, however, that people are not well aware of all the details, the specifics of these incidents. For example, like I mentioned, I mean, the Israeli incident is really recent, but also the Kamuri incident, both of them had attackers trying to manipulate chemical levels, which is something that has, in my opinion, been a little bit underreported. And that's good, because there's also a lot of over-reporting in ICS security where people pretend the world is going to fall apart any moment now, and that's not good for its own reasons. But I do think it is very important that people are aware that these attacks are occurring, and attackers do have an interest in an actual cyber physical impact in these particular incidents.
Okay. Well, time is about up. Jos, I thank you very much for like you've taken us into the Microtech framework and especially with the water sector examples. Really appreciate that. The recording will be online later on. We will mail you, and I thank you all for participating. And goodbye.
Thank you.